In this lesson, we are going to define catalyst and explain its behavior in a chemical reaction, and we will describe how temperatures, concentration, or pressure of a reactant and a catalyst affect the reaction rate. The job of a catalyst is to increase the reaction rate by changing the mechanism of the reaction, which lowers the activation energy. Going back to our analogy of morning versus non-morning people, if you are not a morning person, but your bed suddenly lifted you up and dumped you in the floor when your alarm went off, you have changed the mechanism by which you get out of bed, and this would function as a catalyst because it lowers the activation energy to getting you out of bed and therefore speeds up the reaction rate. Note that a catalyst is present at the beginning and end of a reaction, and it is not consumed in a reaction. Another way to think about the mechanism is to think about a trip. If we start in Kentucky but take some detours, we can still end up in California. So our starting points and end points are the same, but the number of miles that we cover and the path we took vary. And so this is another example of changing the mechanism of a reaction, which is the function of a catalyst. When we look at the energy diagram for a catalyzed reaction, we see that the energy of the reactants and the energy of the products are exactly the same. However, the activation energy is lower. An uncatalyzed reaction has a higher activation energy than our catalyzed reaction. Does a catalyst affect the enthalpy of the reaction? And our answer here is no, because we see that the products and reactants have exactly the same energy. Remember that the enthalpy depends on the energy of the products minus the energy of the reactants. The activation energy does not affect the enthalpy, so a presence of a catalyst or lack of a catalyst will not affect the enthalpy of a reaction. Later in the course, we will discuss enzymes, and enzymes are simply biological catalysts. For example, lactase, shown here, helps to break down lactose. So someone who is lactose intolerant lacks enough lactase to break down the lactose. Most every biological reaction in our body has an enzyme that functions to help speed up that reaction. And in fact, without those enzymes, we could not survive because the reactions would happen so slowly that we would not get the nutrients and components that we need from our larger molecules that we consume. Collisions between molecules lead to reactions. There are three things that have to happen in order for the reaction to occur. 1. Molecules actually have to collide with one another. If they don't collide, they don't interact, they don't react. The molecules must collide at the correct orientation, and they must collide with sufficient energy. The best analogy to this is Legos. If I take the tops of two Legos, I can hit them together all day long. So they're colliding, but that's not enough. They're not colliding with the correct orientation in order for the reaction to occur. If I then take the top of one Lego and the bottom of another, I can still make those two molecules collide, and I can collide them with the correct orientation, but if they don't have enough energy, they're not going to stick together. So all three of these factors have to be in place in order for a reaction to occur. One thing we see is that the temperature affects the reaction rate. As the temperature increases, the reaction rate increases. The amount of increase can vary from reaction to reaction, but we will see an increase. As we increase the temperature of molecules, their speed increases. Because their speed is increasing, the energy of the collision is also increasing. And as a result, we have more collisions which meet the barrier of having sufficient energy for the reaction to occur. This diagram helps us picture what's going on when we increase the temperature. Notice that as we increase the temperature, we see a shift towards the right of increasing kinetic energy, and kinetic energy is relative to the speed of molecules. As we increase the temperature and the curve shifts, we see a change in the shape of the reaction curve. We see more molecules having that higher energy, and so they have enough energy to overcome the activation energy for the reaction to actually occur. Another factor which affects the rate of the reaction is increasing the concentration or pressure. If we have fewer molecules, we have fewer collisions. The more molecules we have in a space, the more collisions we have. The more collisions we have, the more effective collisions we will have that are at the correct orientation and with sufficient energy for the reaction to occur.